Hi students, in this video I'll be going through the 2023 paper 1 question 4a and 4b part 1. Right, so this is a question regarding perfect squares and perfect cube. Alright, so let's read part A of the question. So part A states that m equals to p to the power of 16 times q to the power of 8 times r to the power of 12, where p, q, and r are prime numbers. Okay, so explain why m is a perfect square. Okay, so before we settle on the answer, I would like to go through some commonly presented answers, right? So the first answer that is commonly presented is that the powers of P, Q, and R are even numbers or multiples of 2. Okay, so I would like to briefly go through why this answer may not be appropriate or may not be good enough. Okay, so the thing about this is that even numbers, right? Even numbers can also include negative numbers. So numbers like -2 and -4 are also even numbers. Okay, this goes similarly for multiples of 2. So -6 and -8 are also multiples of 2. Alright, so in this question, they didn't give you a P, Q, and R. But in another question, if they're given numbers for P, Q, and R, let's say they say that P is 2, and let's say this 2, you say that it's even number, right? So what if I have a -2 as an even number? Will this still be a perfect square or not? Okay, so let's say m is 2 to the power of -2 times 3 to the power of 4. Okay, so we know that according to the law of indices, if you have a negative power, okay, then you can express it in this form, right? 1 over 2 square. So 3 to the power of 4 is just 81. So 1 over 2 square is 1/4 times 81. So end up with 81 over 4. Okay, so this number over here is not a perfect square, because a perfect square, if you know it very well, perfect square has to be an integer. Okay, so this 81 over 4 is not a perfect square. Okay, so this is why I feel that this answer is not good enough. Okay, because if the powers are negative even numbers, then the number overall will not be a perfect square. All right, so I would feel that moving forward, it will be best if you avoid writing it in this way. All right. Okay, let's look at another answer that is commonly given. M can be square rooted. Okay, if you write just this, it's definitely a wrong answer already. Okay, an incorrect answer. Because every number can be square rooted. Every positive number can be square rooted. You can square root 2.5. You can square root 3 over 10. You can square root any positive number to get a real answer. Okay, it's just that whether you will get an integer as an answer or a fraction or decimal as an answer only. So if you just write this, m can be square rooted, this is definitely wrong. Okay, so if you want to get it correct, you have to include this. Okay, m can be square rooted to give an integer. Okay, this is indeed nothing wrong with if you write it as a whole statement like this. Okay, because we know that perfect square, one example is 4, right? So if you square root of 4, you get 2. So this 2 is an integer, right? To give an integer, okay, 2. So 4 will be a perfect square. Okay, so if you square root, let's say 9, you get 3. So it's still an integer, right? So these two are integers, right? So any number that you can square root to get integer would be a perfect square. Okay, so this answer is technically okay. Okay, but I will feel that this is not the best way to represent the answer. Okay, so I would like to present to you one way to present the answer. So what you can write is that you can say that m can be expressed as the square of an integer. Okay, why I like this definition is this. Okay, because now you're asked to explain, right, why is a perfect square. Okay, why is a perfect square? So I would like to relate this directly to the definition itself, or my answer itself. All right. So if they ask you to explain why is it a perfect square, so you say that m can be expressed as an integer, as a square of an integer. Okay, so let's run through the first few perfect squares. So we know that 1 is a perfect square, right? So 1 can be expressed as 1 square. So this is the integer, okay, the square of an integer, right? So the next one would be 4. Okay, so 4 is 2 square. So now this 2 is the integer, right? Over here, this is the integer. So now you can express as a square of an integer. So we can go on for more. 3 square. 16 would be 4 square, and then 25 would be 5 square. So you see, any number that can be expressed as an integer square will qualify as a perfect square. Okay, and the word square appears inside your explanation, and it fits perfectly to that what they want you to explain, a perfect square, right? So this will also help you to remember, okay, more easily, okay, how you can explain, okay, why a number is a perfect square. Okay, so this one I would feel would be the best way or the easiest way to explain why something is a perfect square. Okay, anyway, let's try to apply this idea to this question itself. So m is given to you as p power 16 times q to the power of 8 times r to the power of 12. Okay, so remember, we want to try to express m now as the square of an integer, right? Okay, so let's try to break down this m okay, to form a square of an integer. Okay, so m is p to the power of 16 times q to the power of 8 times r to the power of 12. Okay, so now we want to try to break down this m, right, into something times something, okay? And both things that are inside should be an integer, and they should be the same integer, right? So you see, we have p to the power of 16. So if we want to break up into two groups, it will be p power 8 and p power 8, right? Okay, then q is power 8. If you break up into two groups, it will be q4 times q4. Okay, then R12 will break up into R6 times R6. Okay, so now we have broken up into two groups, right, which are exactly the same. So we can now express it as the square of an integer already. Okay, so Q4 times R6 square. Right, so now we can just write one statement. So for explanation question, it's actually important to always try to conclude with a simple statement. All right, so what we can say is that p to the power of 8 times q to the power of 4 times r to the power of 6. So since p, q, r are all prime numbers, this one will definitely be an integer, right? So we should write it's an integer. Okay. So m will be equals to an integer square. Okay. So this whole thing is the integer, right? Okay. So m will be an integer square, and hence it is a perfect square. Okay, so this is the way I recommend you to present your answer when you are asked to explain why something is a perfect square. Just try to group it such that you are able to form something square, integer square, right? Okay, so hopefully this is useful for you. Okay, so the definition, the one that I feel would be the best would be to say that m can be expressed as the square of an integer. Okay, because it actually addresses the term perfect square very directly. Okay. Okay, now let's apply this idea, right, to a perfect cube. Okay, so they say that in part B, 1, they say that the number s is equals to 2 power 8 times 7 to the power of 10 times 11 to the power of 15. All right, so they say that there's this number n, there's a perfect cube, and n is s times k. Okay, so let's try to work this out. So s times k is a perfect cube, right? Perfect cube, right? Okay, so if a perfect square is the square of an integer, then a perfect cube will be the cube of an integer, right? So this number, this perfect cube over here is actually the cube of an integer. It is a cube of an integer. Okay, so if we can express this s times k as a cube of an integer, then it will become a perfect cube. Right, so over here, they have given us the value of s already in a prime factorized form. So we'll just replace it into the question. So we have this. Okay, then now we are going to multiply by k. Okay, so I'm going to change the color of the pen. Okay, so k over here. Okay, then we're going to change back to this. So equal. Okay, so now, okay, let me change the size. Okay. Okay. Okay, so K. Okay, then change back. Okay, so equal to a perfect cube, right? Okay, so as mentioned, we want to express it as a cube of an integer. Okay, so we try to break this up into three groups. Okay, so for square, you break it up into two groups. For cube, you break it up into three groups. Okay, so now let's try to break this 2 to the power of 8 into three groups. So 2 to the power of 8 cannot be broken up into exactly three groups. So we try to break them up as evenly as possible. Okay, so if you think about it, you will be able to break it up as 2 cube, 2 cube, and 2 square. Okay, because 2 to the power of 3 times 2 to the power of 3 times 2 to the power of 2 will give you 2 to the power of 3 plus 3 plus 2, right? Okay, based on the law of indices. Okay, so we try to break up as evenly as possible. Okay, then let's take a look at the next one. Okay, so 7 to the power of 10. Okay, how can we break it up as evenly as possible? Okay, so after a while, you should be able to figure out that you can break up into 7 power 4. Okay, times 7 power 4, times 7 power 3 times 7 power 3. Okay, okay, 7 power 3 times 7 power 3. Right? Okay, then 11 to the power of 15. Okay, 15, okay, can be divided into 3, right? Again, 15 will be 5 times 3. Okay, so this one will already be able to break up exactly, okay, between the three groups. So this will be 11 power 5 times 11 power 5 times 11 power 5. Okay, so now our aim is to make these three groups exactly the same, right? So that we can express it as something cube, right? Okay, so over here you have 2 cube, 2 cube, and 2 square over here. Okay, so what we are missing is 1, 2 from here, right? Right? Because if I add another 2, 2 square times 2 will give me the 2 cube. Okay, over here we have 7 power 4. Here is 7 power 3, 7 power 3. So this means that we need to top up 7 over here and here. Right, the 11 power 5 is already the same between the three groups, so we don't have to do anything else. Okay, so from here we can see that this K, K which is in red, will be 7 times 2 times 7. Right, so K from over here will be 7 times 2 times 7. Okay, basically we just extract all the extra terms that you added in, and that will be the value of K already. So K is going to be as a product of its prime factor. Okay, so be careful. You want a product of its prime factors, so we should just write 2 times 7 squared. Okay, instead of calculating out as 98. Okay, so once we have done this, you realize that now this number is a perfect cube already. Why is it a perfect cube? Because it can now be expressed in this form. Okay, cube. Okay, where the thing inside this bracket, this whole thing, if you combine together, is definitely going to be an integer. Okay, so you are able to express this number as a cube of an integer, and that is why it's a perfect cube. Okay, so this is the way I feel it will be easier for you to remember. A perfect square is a number that can be represented as a square of an integer. Here, a perfect cube is a number that can be represented as the cube of an integer. Alright, so this will be the way I feel will be easier for you to remember. Okay, so I hope that is useful for you.